Hi students, I am your Vivek Vishal sir. We are into the NEET series and today I have taken laws of motion. This is very important chapter that you must go through and this is a conceptual chapter. So all other chapters are they require these concepts of these some small concepts of these chapters. So and they ask definitely some 2 or 3 questions from this chapter in both NEET and JEE mains. Okay, so let's start without wasting time. So see, laws of motion. Now first thing that we need to understand, that is the definition of force. Like we all studied in our earlier classes that force is equals to mass into acceleration. Now let's have a better clarity of force, some updated version of the definition of force. So force is basically defined as rate of change of momentum. Rate means what? No, not that rate. Rate means how much momentum is changing divided by time. When you divide something by time, rate of change of momentum. Mom means not mom dad, momentum, that mom. Okay, so see, if I see the magnitude of this force, so this is dp by dt. Now we can write this momentum as mass into velocity. Now suppose mass is constant. Again, if mass is constant, then we can write m dv by dt. Mass will be taken outside, dv by dt. Now what is dv by dt? Acceleration. See, here it comes, mass into acceleration. So force, you should remember these formulas. Force equals to rate of change of momentum. Now what kind of questions they can ask? See, first type, they can ask that if P is T square plus 2T, what is the force at T equals to 1 second? So you can do F equals to dP by dt. So you have to differentiate momentum with respect to T. So T square differentiation will be 2T plus 2T differentiation 2. Time it's given 1. So 2 into 1 plus 2, that is 2 plus 2, that is 4 Newton. The SI unit of force is Newton. Force SI unit is Newton. Or you can write force is mass into acceleration. This mass is kg, acceleration is meter per second square. So 1 kg meter per second square is Newton. The CGS unit is dyne. Not that dyne. Not that dyne. This is dyne, CGS unit of force. And 1 Newton, you remember this, equals to 10 power 5 dyne. Okay. So these things you need to remember. So this is one kind of question they can ask, that what is the force here. So force we calculated 4 Newton. Now another thing, what I told, like if we have graph kind of question, this is momentum, this is time, this is A, this is B. They're asking force acting on A is greater than force acting on B. Whether this is true or false. True or false you have to tell. Now we know that force equals to dP by dt. Now if this is y versus x graph, what is dy by dx? Slope. So if it is P versus T graph, what will be the slope? dP by dt. Again, what I am saying, what is the general formula for slope? dy by dx. But here in place of y we have p and in place of x we have t. So we can write dp by dt. And dp by dt is nothing but force. So slope of p versus t graph, pt graph, is nothing but force. Okay. So you can see slope of A is more. And what is slope? Force. Means force on A is more than force on B. So this statement is true. You can see the force, that slope of A is more and slope is nothing but force. So force on particle A is more than force on particle B. This is one kind of question they can make. Next. From this formula that force equals to rate of change of momentum, that is dp by dt, if I do cross multiplication, what can I write? dp equals to f dt. If I integrate both the sides, so I can integrate like this. Now the integration of dx is x, so integration of dp will be p from initial to final. Integration of f dt. So final momentum minus initial momentum, upper limit minus lower limit, equals to integration of f dt. They can form the question from here. And this change in momentum, what is pf minus pi? Final momentum minus initial momentum means change in momentum. This is called change in momentum. Change in momentum. Or we have another word for this. This is also called impulse. This change in momentum is also called impulse. Correct? So if they ask you to find the change in momentum, you can find by this method. Now, again I am saying, again stick to the basics. If y versus x graph is there, if I ask what is the area under the graph, this concept is used in all chapters. So area under the graph, you will say it's an integration of y dx. But if I say, if here we have, in place of y versus x, we have f versus t graph. So area under the graph will be integration of f dt. And what is f dt? Impulse or change in momentum. Means change in momentum or impulse you can find by this formula, final momentum minus initial momentum, or integration of f dt, or area under ft curve, area under ft graph. Okay, so this is very important. The area under ft graph will give change in momentum or impulse. Correct? So always remember these points. These points are really very, very important. Like for example, they can ask like some questions I am taking, like f is given as 2t plus 5. From t equals to 0 to t equals to 2, they want to know what is the change in momentum or what is the impulse or change in momentum. So what you can do? So impulse or change in momentum is, see, this is the solution I am writing, integration of f dt. So integration of f is 2t plus 5 dt. We can integrate 2t dt, integration of 2t dt plus integration of 5 dt. So 2t dt integration will be 2t square by 2 plus 5 dt integration will be t. So these 2 will be cancelled. So t square plus 5t. limit you have to set. From time equals to 0 to time equals to 2, you set the limit and you will get the answer. Upper limit minus lower limit. Correct? So this way we can find a change in momentum or impulse. Correct? So these kind of questions can be asked. They can give the graph also. And they can ask what is the change in momentum. So area under the FT graph, you calculate the area and you will get this change in momentum value. Okay. Next. Now suppose they have given there is a wall like this and there is a ball which is coming in this direction. After striking this ball, it is following the laws of reflection and the ball is returning back in this direction. So this is the wall and there is a ball which was traveling with some speed v in this direction. After striking this wall, it follows the laws of reflection. First of all, laws of reflection means, or you can say it's given in the question, collision is elastic. Collision is elastic. Means first of all, after striking the wall, its speed is not going to change. Its speed will be v only, and it will also follow the laws of reflection. Means this angle and this angle should be same. Angle of incidence and angle of reflection should be same. Suppose they have given this angle as theta. This angle as theta. So this angle will also be theta, alternate interior angles. This angle will also be theta, alternate interior angles. Now what was the question? Again I am saying the question. My question is, suppose a ball is projected like this with a speed v. With a speed how much? V. Making an angle theta with the horizontal line. It strikes the wall and follows this path and the collision is elastic. Means final speed is also v. They are asking find change in momentum. What will be the change in momentum? Correct. So see how we have to do. We are going to solve this question in x direction separately, in y direction separately. Why? We can see this velocity we can resolve in two components. This velocity you can resolve in two components. Means for example, I am resolving, suppose this is v, so this is what? V cos theta. And this will be what? V sin theta. Correct? Similarly here, if this is v, here, after striking the wall, if this is v, you can make, like you can see, this is v. Wait, just. If this is v and this is theta, so this component will be v cos theta and this component will be v sin theta. What I am saying, see here, that after striking, this is v, correct? And this angle, you see this angle, this dotted line, this is theta. So if I write its two component, so this will be v cos theta and this will be v sin theta. Correct? So this is the initial scene, this is the final scene. Now what we are going to do? We are going to solve the change in momentum in x direction separately, in y direction separately. So if I write, So if I write what is the change in momentum in x direction, see here, change in momentum delta p in x direction means final momentum in x direction minus initial momentum in x direction. So final momentum in x direction, momentum is mass, final velocity in x direction. You can see final is this C. So x direction v cos theta. So value is m, momentum is mass into velocity. Velocity is how much in x direction? V cos theta. Since it is a vector quantity, momentum is a vector quantity, mass into velocity, you have to see the direction also. It is going in the left direction or west direction. So you can write minus I cap. This is the final momentum in x direction minus initial momentum in x direction. Initially mass is m, velocity is v cos theta, direction is I cap. See here. So mass, velocity is v cos theta, direction is I cap. So minus mv cos theta I cap minus mv cos theta I cap, it becomes minus 2 mv cos theta I cap. Now if I write a change in momentum in y direction, see. So again final momentum in y direction minus initial momentum in y direction. So final momentum in y direction, this is mass, velocity is v sine theta and direction is down. So we can write minus j cap minus final momentum we have written minus initial momentum in y direction. So again mass is m, velocity is v sine theta and direction is what? Minus j cap. So again you have to write minus j cap. Now see here, minus minus will become plus. So this will be plus mv sine theta and minus mv sine theta, j cap j cap. So it will cancel and it will become 0. So there is no change in momentum in y direction, you can see. There is no change in momentum. Change in momentum in y direction is 0. However, we got change in momentum in x direction, which is minus 2 mv cos theta I cap. So net change will be this only, minus 2 mv cos theta I cap. They ask what is the net change in momentum. So here is this 0 and here is minus 2 mv cos theta. So net will be what? Minus 2 mv cos theta I cap. This is the net change in momentum. This you need to remember. Not remember, you have to understand the concept behind this, so that you can solve any kind of question related to this they ask. They might give you values. You have to substitute the values and get the answer. Okay? Okay. Next. See, one Lami's theorem. Lami's theorem. What it says, that suppose there is a particle, object, and like forces are acting on it, like this. This is F1, this is F2, this is F3. Okay. All going away from the object. All these forces are acting away from the object. This you should remember. All these three forces should act away from the object. And the body is in equilibrium. So body is in equilibrium. Body is in equilibrium. Forces acting away. Three force system, means total three forces are acting on it. Then what we can write, what is Lami's theorem? What it says, that suppose this angle I write x, this angle I write y, and this angle I write z. Then what Lami's theorem says, that F1 by sine of opposite angle, the angle which is opposite to this force. Opposite to this force means this angle x, the angle formed by 2 and 3, that is sine of x, is equals to F2, that is another force, divided by opposite angle, means angle formed by F1 and F3, that is y, is equals to F3 divided by opposite angle, that is z. Here you have to write sine y, sine z. This is Lami's theorem. This is Lami's theorem that you need to remember. Next, see, free body diagram, FBD. So free body diagram means whenever there is an object which is acted upon by some multiple forces, so we draw all the forces acting on the object and we see its acceleration and all. So this is free body diagram. So before free body diagram, I need to tell you some 2-3 concepts. That first of all, tension. Tension. See, suppose there is one object like this, and there is a string like this. Okay. And you are pulling this object with the help of string. Okay. So there, like if you are pulling and the object is getting like displaced, you think like in this example, it will be more clear. For example, see, like this. There is one string attached to this object. The mass of the object is m. Right now, what you can see, if the object is at rest, the string is tight. Okay. Now, if I see what forces are acting on this mass, so you will say one gravity, mg, and something is supporting it so that it is at rest. Means an upward force is acting. An upward force is acting, that is force. If there was no string, there was no force. The body will fall down. Means there is some force which acts upward. This is called tension in the string. And these two forces are equal. We can write tension equals to mg. Okay. So there is one object like this and the string is like this. The string is like this. If someone asks what is the tension in the string, we will write 0 because there is no tightness in the string. So tension, basically we can feel like tightness in the string. Force of tightness. Tightness in the string. So right now there is no tension, there is no tightness in the string. So tension, we will say it is 0. Acha. With the help of string, what we can feel, you only tell me that whether with the help of this string, whether we will be able to push this object. Push. If I say that with the help of this string, you push this object. Like from here to here, push. It is here right now, the object is here. You push it from this side to this side with the help of this loose string. Can you push? No. Means you won't be able to push this object because you know the string is slack. But if I say with the help of this string, can you pull the object? Can you pull the object? Your answer will be yes, sir. We can pull it like this. With the help of this string, we can pull an object. Because when we are pulling the object, the string will become tight. And this tightness or the force of tightening is called tension in the string. So here there will be tension